welcome back. We are still on the chemical properties of an alkalis. We have discussed the first two that say that it can neutralize an acid to give us salt and water, and also we have a word with ammonium compound to give us what? Ammonia gas. Now the third one is that an alkalis reacts with a solution of metal salts to form a metal hydroxide. All right, so for example, this is a metal salt, okay, iron 3 chloride, reacting with what? With sodium hydroxide. So what is formed is what? Is an hydroxide, okay, gotten from where? Gotten from the base, all right? So whenever a metal salt reacts with the base, it always gives us what? A metal hydroxide, and a salt is formed. And this salt is formed is always a normal salt. Another example is when we react copper 2 sulfate. This is copper 2 sulfate with what? With sodium hydroxide. I will give us what? Copper 2 hydroxide. Don't forget, metal hydroxide. Iron 3 hydroxide. Copper 2 hydroxide with a normal salt formed at the end of the reaction. So these are the three basic chemical properties of what? Of bases. All right, so let's look at some uses of a base. So bases are used in the making of soap. As I said before, that we have the major is sodium hydroxide and also potassium hydroxide. So calcium hydroxide is used in the making of mortar, plaster of Paris, whitewash, cement, in sugar refining and neutralization of soil or acidity. Then ammonia is used in what? In making fertilizers and detergents. So these are other what? Uses of what? Of a base. Okay, just look at the screen and see what they are being used for. All right, so let's proceed. Our next subtopic here is salts. Okay, so under this topic, we're going to look at definition of salt and their types, the method of preparation, their characteristics, and lastly, the uses of salt. Okay, so this picture shows how salts are being produced. All of these illustrate what we call neutralization reaction. All right. Now this is your burette. All right, and this is your what? Analyte. Okay, this is your base. Acid is in the burette, and you titrate. All right, with your indicator. So at the end of the titration, you have a color change, meaning that this is where what? The salt is formed by reacting what? Reacting a base. Okay, reacting a base with an acid to give us what? Salt and water. How do you get the salt? By passing through heat. If you heat this compound, water will evaporate and the salt will remain at the base, depending on what? On the kind of acid and the kind of base that you use. You not determine whether the salt is going to be an acid salt, basic salt, or a normal salt. So this is how salt is produced. And the whole of this is known as what? Titration process. Is that okay? All right. And illustrate what? Neutralization reaction. Okay, these are some classes of salt. We have some white salt, pink salt, gray salt, black salt, red salt, and so on and so forth. Okay, just to show us the colors of some salts. So what are the types of salts? We have basically 5 types of salts. We have what we call the normal salt, the acidic salt, the basic salt, double salt, and the complex salts. So let's start from the first one, which is the normal salt. Now, normal salt is formed when there is a complete neutralization, okay, of acid. All right, for example, this is your hydrochloric acid, all right, being completely neutralized by what? Sodium hydroxide to give us what? Sodium chloride. All right, so this is example of what? Of a normal salt, where there is no presence of what? Of hydrogen ion. Don't forget that what is an acid? Acid contains what? Contains H+. When dissolved in water. What of a base? A base contains hydroxide ion when dissolved in water. But if a compound is a normal salt, you will not see this, and neither will you see what this. So this is a normal salt. That always is eatable salts. Another one is zinc sulfate, gotten from where? From tetraoxosulfuric acid with zinc oxide. All right. and water is given as what as a byproduct. So how is it formed? When there is a what? Complete replacement, all right, by metallic ions or ammonium ions, okay, from the acid. That means that the metallic acid do what? Replace all the H plus present in the acid. You can look at it now. Now what happened there? Sodium had completely replaced hydrogen from its compound, and it gives us what? Sodium chloride. Okay? If you look at the breakdown, this is minus, this is what? Plus. This is minus, this is plus. So what happened? This OH takes up the plus and form what? Water. Okay? While the sodium ion takes up what? The chloride ion, and it forms what? The sodium chloride. And the normal salt is formed. Complete replacement of the what? Of the hydrogen ion. Complete neutralization has taken place, and you have what? A normal salt. Okay, so let's look at another type of salt, which is the basic salt. Now, this salt is formed when there is insufficient supply, mark the word, insufficient supply of acid for complete neutralization. Is that okay? So a basic salt will turn red litmus paper blue and will react with excess acid to form a normal salt. So when a basic salt is formed, for example, this is zinc hydroxide chloride. Okay, basic salt. Now what makes it basic? Because of the presence of what? Of OH in this. That's the difference. As you can see now, this one here contains no OH. So from the basic, you have what? A normal salt. So a normal salt can be formed from where? From a basic salt when it reacts with what? With an acid. Is that okay? So the difference is that all basic salts must contain OH. This is a basic salt, this is a basic salt. And when the salt now reacts with an acid, what happens? It gives us what? A normal salt at the end of the reaction. Okay. Acid salt. Acid salt is formed when the replaceable hydrogen ion in acid are only partially replaced by a metal and are acidic what to litmus paper. What do you understand? What do you mean by that? Now this is my what? My acid H2SO4. This is my what? My base. All right. Now what happened here? There is a partial replacement by what? Of metal. Okay, so that means that the acid is not enough to neutralize what? The base. That's why you have what? A presence of H present in the salt. Don't forget that this salt is no longer a normal salt because we have an element of acid present in the salt. And the presence of this H make it what? Make it an acidic salt that can act as an acid, even if it's a salt. Okay, because it contains what? H plus. That makes a salt what? An acidic in nature. Is that okay? So we have other examples, okay? Then the next one is called the double salt. For the word double means what? When you ionize in water, it gives us more what? More ions. For example, we have KlSO4.12H2O. All right? So different type of ions are formed in a double salt. Example is alum or aluminum potassium trioxosulfate 6-dodecahydrate. All right. So when this compound dissociates, you're going to have 3 ions from this compound, which are what and what? You're going to have potassium ion, which is from the potassium we have here. You're going to have what? Aluminum ion, Al30 plus. Okay. You're going to have what? The sulfate 6 ion. So that makes a salt what? A double salt. 3 ions are present in one compound when they what? Dissociate in water. Then the last one is a complex salt. Okay, when you mix 2 simple salts together, okay, when you mix 2 simple salts together, what you have is a complex salt. For example, you have ZNaZNOH close than 4, we have K4FeCN, and so on and so forth. So those are the 5 basic types of salts that we have. All right, let's proceed and look at some characteristics of salts. Okay, so salts contain water of crystallization. What does that mean? water that is chemically bound to a salt. All right? So this is what, there's a dot here, don't forget. 7H2O. I mean, this water contains what? Contains 7 molecules of water. Iron 2 sulfate contains what? 7 molecules. Then sodium trisulfite contains what? 10 molecules of what? Of water. So this is called what? Water of crystallization. All right. So when this happens, it's not all salts that do what that contain this. All right. So some salts are efflorescent. What does that mean? Substance that loses what? Its water of crystallization. Okay, when exposed to the atmosphere. For example, this is sodium trioxocarbonate, what? 4. Decahydrates. 10 means what? Deca. So when you expose this salt to atmosphere, it will lose, if not all, part of the molecule of water present. So if this happens, this compound can be reduced to CaNO3 dot H2O. Okay? Means that you have lost what? It has lost 9. It can be 9, it has lost 1, and so on and so forth. Okay? So whenever there is a reduction in the molecule of water, that means that salt undergoes what? Efflorescence. Now, efflorescence is a process, okay, whereby a salt loses what? Its water of crystallization when exposed to the atmosphere. But the salt themselves are called what? Efflorescent. So this is an efflorescent compound. All right? This is an efflorescent, but the process is called what? Efflorescence. You only change this letter, add word CE. Efflorescence. Okay? Is a process, but efflorescence is a substance, which is what? Example is this and this. Okay, another example of salt is that they can absorb water of what? Water from the atmosphere and dissolve in it to form a solution. So whenever a salt, okay, undergoes such process, all right, is called deliquescence. As usual, not deliquescent. Deliquescent are compound themselves, okay, but the process is called what? Deliquescence. Please don't mix up the concepts. So this is a process, all right? But the substance itself are called what? Deliquescent, all right? So they absorb water from the atmosphere and dissolve and becomes what? Solution entirely. All right. Then hygroscopic is somehow like deliquescence, but it's not complete deliquescence. In the case of hygroscopic, they will absorb water from atmosphere, but they will not form solution with it. Whether they become moist or sticky, all right? Become moist or what? Or sticky. Example is sulfuric acid, okay, copper 2 oxide, and a quicklime. All right. When you expose this kind of compound, all right, to the atmosphere, it will not form solution like the liquescence, but there is water in it. It becomes moist, or some tests call sticky. So these are the major characteristics of salt. I said they are efflorescent, they are deliquescent, they are also what? Hygroscopic in nature. So let's look at some uses of it. We have many uses. I'll give you just few. For example, sodium hydroxide is used in preservation. Most times, most of our mother will just pour salt, okay, on what? A fresh fish and exposed to what? Sunlight. It will absorb the water and preserve the fish, all right? So salt are used as drying agents, okay, as antifreeze. Then salt is also used what? In making soup, okay, to separate soup from what? From glycerin. And we have many more what? Uses of salt. Okay, let's go for a brief break. We will come back and continue from there. Stay tuned.